Hello students, in the last session we discussed parallel plate capacitors. You could understand how to derive the capacitance of a parallel plate capacitor, and today in this video we will discuss how the capacitance of a parallel plate capacitor varies when a dielectric medium, that is insulating medium, is introduced between the plates. To understand this, we need to discuss first what is the effect of electric field on a dielectric. That is the phenomenon of what we call dielectric polarization. Let us discuss this in detail first, and then we will apply it to a parallel plate capacitor. Okay. So what to discuss? Dielectric polarization. Dielectrics may be dielectrics are non-conducting substances. What are dielectric? Dielectric just insulators. Dielectric may be of two kinds, non-polar and polar. Non-polar means when center of gravity of positive charge and center of gravity of negative charge coincide together, then this is non-polar. When center of gravity of positive charge and center of gravity of negative charge are little separated, then they are called polar. HCl is polar covalent compound, so it forms a polar dielectric. H2 both HH, therefore it is non-polar dielectric. These are two types of dielectrics. Now we will discuss what happens when electric field applied to the dielectrics. To understand the effect of electric field on dielectric, let me remind you one thing. When we apply some electric field on a conductor, what happens? Induction takes place. Induction means the separation of charges. But in case of conductor, what happens? Electrons are available free to move from one point to another. Free charges are there. So due to effect of electric field, what happens? Electrons are separated and they gather at the two ends until the electric field inside the conductor becomes zero. But in case of insulator, that is little different. So this is electric field, electric field, and a conductor is placed. What happens? Induction will take place. Negative charges will gather here, positive charges will gather in this direction. That is, positive charges will move in the direction of electric field. And now this process continues till electric field due to induced charge and electric field due to the external electric field, they seize each other. The net electric field inside the conductor will become zero. But in case of dielectric, if we keep a dielectric in an electric field, then what happens? This is a polar dielectric. Then what happens in case of a polar dielectric, this is non-polar dielectric. What happens in case of non-polar dielectric? Stretching occurs. That is, the separation of center of gravity of negative charge and positive charge occurs. And negative charges will be oriented opposite to the direction of electric field. In case of polar dielectrics, what happens? Due to thermal agitation, they will be at random in all direction, like this. Let me show you. This will be like this in all direction. But now, due to the presence of the electric field, they will be aligned like this. So that the dipole moment will be directed in the direction of electric field. So whether stretching or reorientation, the result is some development of net molecular dipole moment. Net non-zero dipole moment is developed. Here also net molecular dipole moment is developed. So what is the result of application of electric field on a dielectric? Molecular dipole moment is developed. But how to measure this? What is the extent of this separation or development of the molecular dipole moment? How to measure this? Okay, let us discuss. This phenomenon is called dielectric polarization. Okay, so how to measure the dielectric polarization? This polarization. This is measured by the dipole moment. Developed per unit volume. Okay, it is represented by vector p. Now this p vector is proportional to what? Epsilon naught into E. E is the applied electric field. Then P is equal to some constant chi. This we read at chi. This is P. Okay, and this chi is called electric susceptibility. This chi represents the extent of polarization. Very simple. So how to measure this polarization? Using the polarization vector P, and chi represents here electric susceptibility. That is up to what extent we can polarize a dipole. Okay.